You're probably familiar with constant voltage sources. Batteries, USB ports, wall adapters and voltage regulators are all examples of constant voltage sources. Constant voltage sources will try to supply constant voltage regardless of the load connected to them. A constant current source will adjust its output voltage to try and push a constant current through a load. This can be useful for charging some types of battery and powering things like lasers, fluorescent tubes and most commonly LEDs. If you're powering an LED with a constant voltage, the current will increase as the LED warms up, which will increase the brightness and reduce the lifespan of the LED. Using a constant current will keep the LED outputting a consistent brightness. The circuit I've used is easiest to understand if it's broken into three parts. I'm using a TL431 voltage reference that's configured to output 2.5 volts. This will keep the output current constant, even if the input voltage changes. The 2.5 volt reference is fed into a 10 kilo ohm potentiometer through a 10 kilo ohm resistor. The resistor halves the maximum voltage, which lets me select a voltage between 0 and 1.25 volts by adjusting the potentiometer. The output of the potentiometer is fed into an op-amp based voltage to current converter. The op-amp changes the resistance of a transistor to control the amount of current flowing through the load. The voltage across a 1 ohm resistor is used to provide feedback to the op-amp. For each amp of current that passes through the resistor, there will be a 1 volt drop. The op-amp will try and keep the voltage drop across the resistor the same as the voltage drop it receives from the potentiometer, so we'll convert 1 volt to 1 amp. High currents will make the resistor warm, so I don't have to use the fan I made in my last video to blow away the charred remains. I had to get a beefier resistor. When soldering components to the board, I used more solder than I usually would to try and decrease the resistance of the power traces. If there's a large difference between the input and output voltage and the current is high, the transistor will put off a metric buttload of heat. To keep it cool, I added some thermal paste and attached a heatsink I salvaged from an old computer. I used some hot glue to secure the heatsink and potentiometer. Hot glue isn't the best choice for a heatsink, but in practice I found it didn't actually get hot enough to melt the glue. I can now select up to around 1.25 amps, and the supply will adjust the output voltage to make the current flow through whatever device it's powering. Thanks for watching. If you've got any suggestions for future projects, please tell me.